Welcome back to video number 3. We're going to be starting here with number 27. And 27 to 30 are all absolute value equations. And remember that absolute value means you could possibly have two answers, because here it doesn't matter what's inside here, but if you want a distance of 3, remember that inside you could either have a positive 3 or negative 3, and both result in the answer of a distance of 3. So what we need to do is take both into account. Now, are the bars alone? Yes, they are. And you want to ask yourself, does this say distance is positive? Yes, it does. So I can make my two equations. Either the inside of the bars could equal 3, or the inside of the bars could equal negative 3 in order to get a positive 3 out. I would solve both of the equations separately by adding 2 here. So we get x equals 5 as an option. And here, if I added 2, I would get x equals negative 1 as an option. So if I plugged these both in, it would make this equation true, and I would graph at 5 and negative 1. That dot could have been better. Number 28, you want to ask yourself if the bars are alone yet. Well, not this time, because we have this darn 5 in front. The 5 is multiplying the bars, so we'd need to divide by 5 first. So we'd have the absolute value of x equals a positive 4. The bars are alone, so this says distance is positive. Check, which means that I can make two possible equations. In order to get a distance of 4, either x has to equal a positive 4 originally, or x to equal a negative 4 in the bars to get a positive result. So my two answers are either 4 or negative 4, so that's what I would graph again. Number 29, this time the bars are definitely not alone, so we can't make our equations until the bars are alone. So let's first move this unattached 2 by adding it on both sides. 3 times the absolute value of 2x minus 2 equals a positive 18. This kind of reminds me of a question we did in class on whiteboards recently. Now the 3 is multiplying the bars. We cannot distribute this in, but we can divide both sides by 3 and get that the absolute value of 2x minus 2 equals a positive 6. Now that the bars are alone, does this say distance is a positive number? Yes, it does. So I again can make two possible equations. Either the inside of the bars can equal positive 6, or the inside of the bars, 2x minus 2, could equal negative 6. And I apologize that I'm running out of room, but for both of these, what I would do first is add 2 on both sides. I'm just going to go over my number line here for the sake of room. So I'd have 2x equaling a positive 8. So one answer is x equals 4, which will be here. And this one, if I added the 2 on both sides, I would get 2x equals a negative 4. So if I divided by 2, I would get x equals negative 2. So either my answer is positive 4 or negative 2. Number 30, my bars are not alone, but what I can do is subtract 10 to the other side first. And if I do that, I would get that the absolute value of x minus 4 is equal to a negative 3. Now that the bars are alone, I ask myself what this says. And this time, we have distance is a negative number. And as we discussed, distance is always positive, so this is impossible. So my answer is no solution. And because it's no solution, I cannot do anything on my number line. Next part is the percent equations we were working on. And remember, the main thing you want to consider is that the word of always means multiply, and the word is always equals. So we want to convert these into equations and then solve for x. So for 31, what, which I could say is x, is equals 32%. Remember, if I want to change a percent into a decimal, the decimal's right here, so I have to move it twice to the left. So this is really 0.32 of times 58. The reason we have to change this into a decimal is because we need these to be like terms. One has a percent and one doesn't, so we need to make sure this is no longer a percent so that we can combine them. If in the calculator I take 0.32 times 58, my answer would be 18.56. Number 32, 15%, which I'm going to change. Again, 15%, decimals here, move it twice to the left. So this is really 0.15 of times what x is equals 12. If I want to get x alone, I have to divide both sides by 0.15. And because I'm taking a big number and just dividing it by a smaller number, you're really dividing by a fraction in a way, so it actually ends up being the reciprocal. So that's why the answer ends up being bigger than the original. 12 divided by 0.15 is really the answer of 80. And later on in the year, I might show you exactly why this gets bigger, maybe even after the test. Number 33, 90 equals what percent? So we don't know the percent this time, so I'm just going to write x percent so I don't forget to change it into a percent of times 120. If I want to get my x alone, I need to get rid of this 120 by dividing both sides. So I'd have x percent equals 90 divided by 20. If I did this in my calculator, you would get a 0.75. I don't know if anybody noticed this, but if you have a 0 on top and bottom, you can cross those out. So this is really the same as 9/12, which is also 0.75. Now 0.75 is not your answer because you need your answer as a percent. So remember, if you have 0.75, you have to move the decimal back over. So my actual answer is 75%. Last types of questions here are when a fraction equals a fraction. And remember, in class, we did an example where we said what fraction is equivalent to 2/3. We said something like 4/6. And we noticed that when we cross multiplied, that this diagonal was 12, and this diagonal also equals 12, which means that if two fractions are equal, you can always cross multiply and the diagonals are equal. So that helped us generalize into something like 34. If I don't want to guess and check what x is, I can cross multiply and solve, meaning 7 times x, this diagonal, is going to be equal to this diagonal, which is 5 times 42. So this would really be 7x equals 210. Divide each side by 7, and I get my answer of x equals 30. And if you don't believe me that this is the answer, feel free to take the 30, plug it back in, and see if 5/7 is really equal to 30 over 42. You could check that in your calculator. Number 35, no matter how complicated this gets, you still have a fraction equaling a fraction, which means that I can cross multiply and I know that the diagonals are equal. So in this case, the 2 is multiplying all of x minus 1, and that should be equal to 3 times 5, or 2 times x minus 1 equals 15. Distribute, 2x minus 2 equals 15. Add the 2 to both sides. Bring my work over here. 2x would equal 17. Not going to be a perfect answer this time. You could either leave your answer as 17/2 or 8.5. And again, feel free, if you want to plug 8.5 back in, you will see that if you divide this in the calculator and this, you will get the same answer. Number 36, fraction equals a fraction, even though it looks uglier, so we can cross multiply. 4 times all of x minus 2 is equal 3 times all of x plus 6. So we have to distribute on both sides. We would get 4x minus 8 equals 3x plus 18. Get those x's together because they're not on the same side. 1x minus 8 equals 18. Add the 8. So it looks like my x value is 18 plus 8, or 26. Number 37, got some negatives, but still fractions equaling fractions means we can cross multiply. Negative 8 times 2x minus 6 should be the same as this diagonal, which is negative 4 times x plus 2. Similar idea to 36, just a little bit more negatives. Negative 16x, negative times negative, positive 48, equals negative 4x minus 8. That's a 2. Negative 4 times positive 2 is negative 8. If I again get my variables together, I'm going to add the 4x over here. Negative 12x plus 48 equals negative 8. Please don't forget that negative should come downwards. To get x alone, I would now move my 48. Negative 12x equals a negative 56. If I divide by negative 12, my answer is not going to be that great. If I take 56 divided by 12 in the calculator, my answer would be 4.666667, which is the same as 4.6 repeating. And the answer is positive because it's negative divided by negative. So it is okay sometimes to not get a perfect answer, okay? So just be aware of that. All right, guys, here are the last two problems, number 38 and 39, still proportion related. Katie's boat used 11 gallons of gas in 5 hours. So what I would do is write a proportion and use the units. 11 gallons is to 5 hours as, at this rate, how many gallons? So we're looking for gallons. So because I used gallons on the top, I should still put gallons on the top also over here. And I'm looking for it, so that's why I call it X. How many gallons will the boat use in 12 hours? So I'd put the 12 hours here, also to be consistent with the units. If the units bother you, feel free to write the proportion without the units. 11 over 5 equals X over 12. If a fraction equals a fraction, you are more than welcome to cross multiply. So we would have 5 times X equals 11 times 12, which is 5X equals 132. If I divide both sides by 5, I get that my X value is 26.4. But remember, because this is a word problem, we have to answer it with a final unit. So I'm looking for gallons, so my answer is 26.4 gallons. You could even say 26.4 gallons in 12 hours. Number 39. The legend on a map, which is that little thing usually in the corner that relates how small something is to how large it is in real life. The legend on a map shows that 1.5 centimeters is the same as or equates to 50 miles. So that means if you measure 1.5 centimeters on a map, that really means 50 miles in real life, is to what distance would be represented by a measurement of 6 centimeters? Now this time we know the 6 centimeters. So again, to be consistent with units, you put the centimeters on the top. We want to know what actual distance would be represented. So you'd put X miles down here. Again, if the units bother you, you could write 1.5 over 50 equals 6 over X. And again, this means that if a fraction equals a fraction again, you're encouraged to cross multiply. So you'd have 1.5x equals 6 times 50, which would be 1.5x equals 300. If you divide both sides by 1.5, because it's being multiplied here, we would get that our x value is 200. But in terms of the problem, that would mean that our actual distance would be 200 miles. Or in other words, on a map, when you see 6 centimeters, that actually represents 200 miles. All right, guys, good luck studying for this test. Notice that I have posted here some good ideas in order to study. The review that I did today is absolutely helpful, but please don't forget about your homework, and please don't forget about your old quiz. All right, thanks, guys. Good luck.